In this short tutorial, I'm going to teach you how you can calculate the initial rate of reaction from studying a graph of a reaction. So in this example, we're going to start with a sketch of a reaction profile. You have to convert your data into a graph to be able to do a calculation that involves a graph. So in this case, we have got time going along the bottom, and then we're looking at the volume of gas, which is a good way of measuring the rate of reaction. Because if you've got a reaction that's producing a gas, and that gas being produced very quickly, so the volume is changing very quickly, that is going to imply a high rate of reaction. Whereas as the reaction progresses, in this case, we're getting a curved shape where the rate of reaction is decreasing towards the end, where you're not getting any gas produced because the reaction is complete, and therefore the rate of reaction is zero. And you can tell the rate of reaction from a curve by looking at its gradient. And a curve does not have one gradient. The gradient of a curve depends where you're looking at it. At the very end, you've got zero gradient because it's flat, so the rate of reaction is zero. Whereas at 4 seconds, you have a very different gradient to what you have at 1 second. And so the rate of reaction is continually changing. So we should be thinking about tangents, which is going to hit at one point, and the gradient of that tangent is going to tell us the rate of reaction. And because we're looking at the initial rate of reaction, we have to draw the tangent through zero. So step 2 is to draw a tangent that passes through zero, or rather hits the curve exactly at zero. So that will look something like this. And because we're interested in the gradient of the tangent, we can actually pick any point on the tangent because the gradient is constant for a straight line. The important thing to remember is you must pick those points on the line and not pick points on the curve. You're looking only at the line. So we were going to go about picking our points for convenience. So the next step is to pick 2 points on the tangent. Key is to make sure the points are on the tangent. You're not looking at the curve. So for convenience, I'm going to pick the point 0, 0 because we know that's definitely on the tangent because it has to be by definition, or rather it should be if it's drawn correctly. And then I'm going to pick a point that's nice and easy to read, which is going to be 0.5 on the time, and that's giving me 0.3 because it's in the middle of the box between 0.2 and 0.4. And we then move on to calculate the gradient. So there's the 2 points that I picked. The formula for gradient is the change in y over the change in x. So for the change in y, you're doing 0.3 minus 0, and for the change in x, you're looking at the x point of 0.5, subtracting 0 from it. And so obviously m is going to be 0.3 over 0.5. M is the variable we use to denote gradient. And then when you evaluate that, you get 0.6. And because we've got time in seconds and volume in milliliters, the units that gives us is milliliters per second. So hopefully this video has been helpful to you, and thank you very much for watching.